All right, so we got applications of integration. So this is on differential equations. So in AP Calc, there are many different types of differential equations. In college, there's in fact a whole course called differential equations, DiffEQs. If you're going to be an engineer, you will take it. So differential equations is the full thing. DiffEQs would be the short. Ours are the type of differential equations that are called separable variables. So typically you'll be given DiffEQs where like the x's and y's are mixed up. They're on one side of the equation. And all of the ones we do, you can separate them so that the x's are on one side of the equation and the y's on the other side of the equation. So that is the type of DiffEQs we'll do. If you take DiffEQs in college, you will now know this type already. You'll already know this type, yeah. Okay, so within this type, I break it up personally into 4 types. Type number 1, no ln or e. So it's all polynomials, radicals, rationals. Things that can be rewritten with exponents. You know, just integer exponents, negative integer exponents, or fractions. Null exponents, but just like exponentials, you know? Okay, these problems are nice because they have steps. It's not like each step is going to be easy, but like every problem in this whole packet, we're going to follow these 5 steps. All right, here's the problem. So I'm given a derivative. So for every differential equation, it's called a differential equation. Differentiable as in derivative. So it's an equation that's a derivative. That's what you're given. Yeah? Equation that's a derivative. And you're also going to be given this thing called an initial condition. And what you do is, so you're given a derivative and you're asked for y. So that's how I know to integrate. If I'm given dy dx and I want y, it's integral. Okay, so the first thing you want to do is separate the variables. You want to
I thought it was d over dx. Because I thought when you took the derivative of y, it was y dx.
It depends. They're both yes and no. So if you have a function, if you're like, you can say like take the derivative of cosine x, or you can say dx cosine x. So if you have a function, you don't, like the y is cosine x. It's kind of like y equals cosine x. Or you could say y equals cosine x, find dy dx.
Okay.
So yeah, if there's a function here, there's no y, but if there's no like function here, then there is a y.
Okay.
Okay. So separate the variables. So there's going to be a couple of steps within one to separate the variables. So I have my x is on, see how I have a y and an x together on the left? So I'm going to multiply by dx on both sides to get it gone from the left side, so I only have y on the left. I'm going to multiply by dx on both sides. Okay, so that cancels, so I have dy equals 4x over y dx. This is step 1 for those keeping track. Do I have all my y's on the left and all my x's on the right? Not yet.
No.
Because I have a y stuck on the right, yes?
Yeah.
So it's over y. So to get it gone from the right, and it's going to pop up on the left, I multiply by y on both sides. So let's do that. It's just y dy.
Oh,
Simple, yeah, you're making it complicated. That's cool. Y dy equals, what's left on the right? Yep. So I have separated my variables. It's always the first step. Yeah. Okay, now let's integrate. So step 2 is integrate. So I'm just going to rewrite it with the integral sign in front of both sides. Just to show that, like, this is me, I'm going to integrate.
why are we integrating?
Because of the way the problem is being asked. It says, here's the derivative. It says, here's the derivative of y. What's y? So to get from the derivative of y to y, you integrate. So this is like the point of the problem. You just needed to separate the variables to like get it. Yeah. Okay, so what's the integral of, let's do the right side first, shall we? What's the integral of 4x?
Oh, the integral.
Mhm.
Over 5x. Is that really
Yeah.
X
So
to
that,
the-
so this x minus 1.
4 over 2.
Mm-hmm.
Oh.
So I'm adding 1 to the exponent, so I get 2.
What did I just do? Let me just.
I don't know, I was doing the same thing.
You added 1 to the wrong thing, to like the coefficient instead of the exponent. That's all. You want to add 1 to the exponent. Okay, so this is the integral. What do I need to add to the end? Nope. Plus c. The dx goes away when you integrate. Okay, on the left side now. Okay, on the left side, it's y works the same way as x. So I add 1 to the exponent. So this is y to the first, right? So it becomes y. Yeah, 1/2 y to the second. I would have to do a plus c. Let me just explain briefly. I'm not going to do it, but here's why. Okay? So let's say I do plus c. These c's don't have to be the same. So I'm going to do like c1 and c2. I can combine, so just look up here. So they each have a plus c. I have to use different variables because they're not necessarily the same c. Yeah? So like this is like a plus c1, this is plus c2. So I can combine these c's to just get 1/2 y squared, 4/2 x cubed. What's a random thing minus a random thing? It's a third random number. So we're not going to do this every time, but so don't copy this down. But do you see how like I don't technically every time you integrate you have to add plus c. But I can just combine my plus c's and make them a single plus c on whatever side I choose. Okay?
So we can do it on that side, not on the
Yeah, so this is my work that I'm going to write every time, a single plus c on the right side. And I'm not going to do plus c on the y side. Okay. Yeah. Okay, so let's just clean this up for a second. 1/2 y squared equals 2x squared plus c. Okay, so that's step 2 is integrate. Step 3, this is a new step, solve for c. Okay, so solve for c, we're going to use what's called an initial condition. Use the initial.
I was going to use this new word like equations.
No, thank God it's not.
I'm
No,
so bad at that.
it's not.
On the SAT, I'm going to get that wrong. I've tried so hard.
There's a bunch of those on the SAT.
It doesn't click.
But a lot of times you can just like the
try.
numbers are simple enough that you can just sort of.
It's
No.
so complex. I try to do it like I'm solving calculus.
Okay, so the initial condition. Okay, so the initial condition has, so you basically sub in the x and y values to solve for c. You sub in the x and y values to solve for c. Okay, so let's annotate this. Y of 0 equals 5. This is my initial condition. So you can either label it like initial condition, or sometimes students label it plus c just because you use it to find plus c. But I'll label it what it is. Initial condition. And let's just label the numbers x and y. So y of 0 equals 5. So 0 is the x. And basically it says y of something equals 5, so y equals 5, so 5 is the y. That's like kind of a weird way to make a point, but it's a way to make a point. Sometimes, most of the time it's just given you as like a point, x comma. But sometimes there were problems and they're like at time 0 you start with 50 trees, and that's an initial condition too. X is 0 and y would be 50. So if you use like the word, so it's called an initial condition because also oftentimes is how much you start with, but not always. Okay, so we ready to do that?
Like the thing yesterday.
Like the thing yesterday. Yeah, exactly. So 1/2, what's the y value? value 0 squared plus c. So c is 25 halves. Do you want to make it 25 halves or 12.5?
I did 25%.
25 halves is c. Okay, so now step 4, substitute c back in. Alright, I'm going to do step 4 over here. So I take my equation. So my equation is 1/2 y squared equals 2x squared. And then it says plus c. But I'm going to do plus, what's c?
25.
Love that. So that's step 4. And then step 5 is we want to solve for y. Get y isolated in just like a y equals. Yeah? So what should I do first to solve for y? Yeah, I agree. That's why I'm by 2. So 1/2 y squared times 2, so it would be y squared equals, what's 2x squared times 2? Plus, there you go. But y is still, it's y squared though, right? It's not y equals square root. What do we have to add when we do square root? We have to add a plus or minus. Square roots do not distribute, okay? So you cannot simplify this as like 2x plus 5. Just don't do that, okay? Distribution is a multiplication thing. It is not an exponent thing. Square roots being the exponent of a half. You don't distribute in exponents. It's not over addition. So just leave it. But now, hold on. I can actually choose between plus and minus. So see how it's y equals either positive or negative? I actually know the y value. Is my y value positive or negative? It is positive. So just like a little note, y equals positive 5. So I'm going to choose the positive case. I'm going to say y equals just square root of 4x squared plus 25. So if you forgot the plus and minus in this case,